So we want to find the volume formed by rotating the quarter circle of x squared plus y squared equals 1 around the line x equals 1. So let's get a picture of what's going on. We only need the quarter circle, so that's the only part I'm going to keep. And we're going to go around the line x equals 1. So here is our surface, and it's getting revolved around this way. So we have a boundary also up here. So we can kind of start to see what this is going to look like. We can see that it's going to have an open center, because this is going to get revolved around, and this is going to get revolved around. So we are going to have a situation where we're doing a big radius minus a little radius. The key now is to identify the two radii. So in looking for the volume, we have pi. We're going to be integrating in the y direction, and we can see that y is going to go from 0 to 1, because we know this is 0, this is 1 here. And this line x equals 1. So that works. The big radius excuse me, is always the same, which is kind of nice. The distance from our axis of rotation is the same whether I check it here or here, and it's always 1. So it's going to be 1 squared is our big radius, and then our small radius is the one that maybe gets a little bit tricky. Notice it's the one that varies right there, and we want to solve this in terms of y, so x equals the square root of 1 minus y squared. Now here's where we got to be a little bit careful. We don't want to just make it that, because notice here, down here when the y value is 0, the radius needs to be 0. So it's actually 1 minus that, because this here, this function, the function here is the distance here. The radius is the opposite side of that. So here's what the function will give us. We want 1 minus that. So let's see how this goes. So 1 minus square root of 1 minus y squared squared dy. So there is our definite integral. Now let's look into calculating this and see what we get. So we have 0 to 1. 1 squared is just 1. This is actually going to get FOILed out. We are going to have 1 minus 2 times square root of 1 minus y squared plus the quantity 1 minus y squared. So that comes from FOILing this out. dy. And now we're going to distribute that negative sign. So pi, we haven't done any integration yet. 1 minus 1 plus 2 times the square root of 1 minus y squared minus the quantity 1 minus y squared dy. Those ones are going to cancel. So pi, I have one more negative to distribute. And what we might do is we might even split this up a little. 1 minus y squared minus 1 plus y squared dy. Because it might be helpful to look at this integral separately. And I'll show you why here. So 2 pi, the integral from 0 to 1 of the square root of 1 minus y squared minus just pi. This was the only one that was doubled. Actually, let's keep that plus pi times y squared minus 1 dy. So all I did was switch around the order there, put a plus between them. 0 to 1, this is a nice basic integral. The reason I separated this one out, this is still our quarter circle, and going from 0 to 1, we have a quarter circle. We have a quarter circle with a radius of 1. So we know that the full circle would have an area of pi, so this has an area of pi fourths. So we have 2 pi times pi over 4, and we could have done this with a trig substitution, but it was a nice little shortcut, plus pi times y cubed over 3 minus y from 0 to 1, which we can do pretty quickly. So here we're going to end up with pi squared over 2 plus pi. Now here, when we put in the 0, the whole thing's going to go away. So we have 1/3 minus 1, or negative 2/3. So we end up with pi squared over 2 minus 2 pi over 3. And this is a volume, so if we were given units, it would be in cubic, whatever those units are cubed, or cubic units.